So you've heard about Bacalhau a whole bunch already. It's a decentralized compute network. One of the key user needs, I think, that we know we all have in building compute over data networks is, as a user, I want to trust that I'll get accurate results out of the thing, right? Otherwise, there's no point in me giving you my job and paying for it. Now, obviously, I think we talked a lot in this track about bad actors and about fraud tolerance, essentially. Like, we need to have a network that is fraud tolerant. There are also other ways for it to go wrong, like faults happen, right? Like, you think you're running the code, but you haven't, or your program crashed for some reason, like it got hit by a cosmic ray. So there has to be also fault tolerance as well. So it doesn't have to be about bad people. So these are the kind of properties that we want, and I'm making a broad claim, which is that as like a first MVP for tolerance is visibility. So if I can make faults or fraud visible, then that is the first step towards being able to tolerate them well. For the MVP with just visibility, maybe it's the user who has to do something, but maybe later on you get a network to do it for you. So there are lots of ways to do this. There's lots of ways to get trust. One of them that we've talked about a lot is reputation, i.e. I'll trust that you will execute my job correctly because I like you, or I trust you for some reason, based on your reputation. One of the ones that we're exploring in Bacalhau at the moment is deterministic verification. Part of the reason that we're doing that is it's because it's the one that is, I suppose, the most technically tractable without having to solve lots of hard problems. Reputation for me is like a scary problem because it also starts to pull in things like identity. That's really scary. I can't handle that. So we're going to look at deterministic verification instead. What is that? What am I talking about? So we've got a user up there at the top, and they want to run a job on the network. So what they do is they send it to 3 different runners, and the runners will run the job and produce data that comes out. So you can see those first 2 runners have produced the same data artifact output. They've produced a nice silver CD emoji, and the other runner has produced a different data artifact output. We're not sure what's different about it, but we can tell that it's different because we're able to run a hash over the output data and get the result, and we can see that they're different. So we have a minority report, which is bad news. What we know from doing that is that something somewhere has gone wrong. One of the runners, or more than one of the runners, have produced not the correct output. However, of course, the lesson from the Tom Cruise minority report is sometimes the minority report is correct. So we can't necessarily just assume that because the majority of the nodes have produced an answer, that they are the ones that are right. They could have colluded in some way, whatever. All we know at this point is that something has gone wrong, and the user needs to investigate why that is, potentially. As I said, there are other ways to build trust. They all have different trade-offs. This is my kind of simplified emoji view. There was a great talk yesterday on incentives and anti-cheating that you should definitely go and watch because it's way more advanced. It's got equations, but I can only handle emojis. So what we need here then is we need to know that our runners are able to produce the same outputs if they run the same code. That makes sense, because we need to be able to run a hash over the output, check that the hashes all match up. However, there is a big problem with this because there's lots of non-determinism in standard execution environments that can just introduce noise into the data, either deliberately or by accident. So wall clocks, for example, if I send the job to 3 nodes, those nodes in distributed systems will never have the same wall time. They will always be starting the job at slightly different times. Even if we really try hard, it can't be done. So you can't use a wall clock. Random numbers, obviously they're random. So that doesn't work. Remote networks, so if I call out to the network and get a resource, maybe I'll get different resources back. Also network failures happen. So maybe if the resource is being served from a CDN and it's meant to be static, I can still just get a network failure, right? Multi-threading, so if I do things across multiple threads and I'm writing output from all of those threads, I will sometimes get the output in a different order because threads get scheduled at different times. Values and garbage memory, so if I look at memory before I've initialized it, which is a thing that you can do if you really want to, maybe you'll see garbage there, and that is dependent on what the node was doing before it was running your job. I can look at thermal noise. So we're building a global compute network that is designed to run in lots of different places. One of those places might be on a Raspberry Pi, which has a analog to digital converter. I can sample the voltage off it and just get random noise essentially from that pin. Big source of non-determinism there. And cosmic rays. So your RAM can be hit by a cosmic ray and one of the bits will shift. That happens. Really hard to remove these. Certainly really hard to remove all of them. And actually, all of the execution stacks, like Docker in particular, they will all, it's like whack-a-mole, right? Trying to get all these things out of your system, really, really difficult to do. So how about instead, we start with a blank slate where we don't have any determinism at all, any non-determinism at all, and then we can selectively choose to bring in features in a way that we know that will be deterministic. So take a good look at this list, because this is all the things that we can't do in the normal way in a deterministic system, but we have ways around that. Let's start from a blank slate. What does that blank slate look like? Right, celebrity number 2, I guess. This is Peter Wang. He gave a talk yesterday on the first day of this conference. It was really, really good. I can't do it justice. Please go and watch his talk. It was great. He's my new idol. But essentially, WebAssembly, it's an assembly language. So it's a language that looks very much like how a processor will execute instructions. It's designed to work in untrusted environments, so i.e. your web browser. It's got no access to anything by default. In the WebAssembly spec, it's literally all just about, I have some data, I can execute it as code. For us in Bacalhau, it's a completely blank slate. It's fully deterministic. If you take one blob of WASM and run it in lots of different places, you're running a deterministic program. It's vanilla. So what we can do is choose to add features into our WASM execution that maintain that determinism without losing the ability to verify it. It's also easier environment to make secure. So a big part of Peter's talk is that actually, if we want to build global compute, we have to do really, really strong sandboxing. Browsers have been doing this for the better part of 20 years or something. They've already got really hardened sandboxes. WebAssembly means that we can reuse a lot of those techniques. So it should be safer for compute providers to run than just running an arbitrary Docker image, which is a nice bonus, I suppose. OK, big news. We now support WebAssembly in Bacalhau, which is cool. So you can now take a WebAssembly blob, either on your local machine or on IPFS. You can attach data to it, and you can run jobs. So I'm going to do a live demo. Is that a good idea? Probably not, but we're going to do it. Here we go. So that was the code that I just put in.
Can you make it bigger?
Bigger. Is that better?
Yeah.
Cool. So I'm going to let it run. So this is a WASM blob that I've built. It's based on, it's a Rust program that I've compiled to WASM. It's based on a Rust library called ImageProc. ImageProc is essentially an image processing library. One of the things that it can do is something called seam carving. OK, it worked. That's really good. Let's go and get the results. Seam carving is where you look at the information in an image to work out what are the least interesting parts. So this was the original. This is actually an image that was generated from our Stable Diffusion Docker image that ran on Bacalhau. The input was colorful fish. You can see it's come out of Stable Diffusion because you've got this slightly weird fish with no head and 2 tails. But actually, I think it's pretty good. I'd put that on my wall or something. It's quite nice. But the program that I ran over it was the seam carving. So what it does, I'll just explain it really quickly because I think it's really interesting. It finds the gradients in the image. So that's the things in the that's basically how much each pixel differs from every other pixel. So that's what that looks like. So You can see in the middle of this fish here, it's quite dark because the reds are all very similar to each other, but on the edges, we're going from colors to black, so that's where the gradients are. It then plots routes through the image of where the gradient changes the least. That's what that looks like. So it's found all the places where you're losing the least information, and then it removes those. So that's what it looks like when it's shrunk. So you can see it's done a pretty good job of like taking out all the black, but keeping all the features. And that is code that's run in WebAssembly on Bacalhau in a native Go executor. So there's no kind of touching anything non-Go at this point. And I think that's quite a non-trivial example. So I'm kind of happy with that as a. And you can go and run that job. So if you've scanned the QR code already, or you can scan it now if you want, that will get you that text that you can run. Another thing to point out here is that I'm running this from IPFS. So this is a WASM program that I have pinned to IPFS via like Estuary, and Bacalhau has gone to get it. So you can go and do the same thing. We can now all just use this seam carving program, which is cool.
Question.
Yes.
What language was the seam carving program?
That was Rust.
Yeah.
Rust is pretty good. They've gone really far on WASM support in Rust. There are other languages that have got good support, as I understand, Go through TinyGo and Zig, which I've never used. Python, I think, also has reasonable support, according to Peter Wang. And I'm sure there's a bunch of other things as well, right? So, although Rust is what I've been using for this. So yeah, what is supported? Okay, well, first piece of info, Bacalhau uses WAS0 as a WASM executor. It's a really fantastic library. Massive kudos to those people because it's a WASM executor that's in pure Go. So there's no C libraries, there's no compiling it. If you can run Go, you can run WASM jobs. So we can run WASM anywhere, which I think deserves its own slide. So these are all the places that we can now run Bacalhau jobs. We can run Bacalhau jobs from a Raspberry Pi in a forest. We can run Bacalhau jobs from a satellite. We can run Bacalhau jobs from your smart fridge. We can run Bacalhau jobs from your phone. And in fact, someone's already done this. Hugo has run a Bacalhau, actually he's run the client on his phone. But actually, in theory, you could run now a WASM job on your phone, which is pretty cool. Like, you don't need Docker anymore. This is interesting. So that's fun. The way we do it specifically is we use the WebAssembly System Interface, or WASI. So WASI is quite a good target for onboarding workloads because lots of languages already support it. You can compile stuff in Rust that targets WASI out of the box. Let me explain a little bit why. So as I said to you, WASM is very vanilla. Out of the box, it doesn't have any interface. Like, you can't put data into it. You can't open files. You can't do anything. WASI is a standard, or a kind of evolving standard for how to do that. So it essentially says, okay, if you target this WASI system interface, you can open files, you can get a clock, you can access random numbers. And then now you're thinking, well, hang on, you said that you can't do all those things. But actually, the way that WAS0 implements WASI is it implements it in a fully deterministic way. So we can give it specific files that we want the job to be able to access, and those can be the same across all nodes. It also implements like a monotonic clock. So essentially we give it a pretend wall time, and that wall time increments by like 1 millisecond every time you execute a WASM instruction. So it should be the same for every point of the job across every node. And then we just use like a pseudo-random number thing, which with a seed, which means that everyone gets the same random numbers, essentially. So it's still deterministic across all nodes. WASI is quite good for this because you don't have a Bacalhau SDK. Like, you don't have to recompile. We'd have to compile, but you don't have to rewrite your programs for Bacalhau. You can just run them. But it's quite early, actually. I think it's being rewritten completely. It has opinions. It's very POSIX-like, which is maybe not like good for Web3. So one of the questions that I'd really like to discuss with this crowd is like, what would we rather have? Would we rather have like a Bacalhau SDK, or can we come up with our own compute over data SDK or system interface that we think is a better fit for like what we're doing in Web3 world? I talked about clocks. Yeah, so in Bacalhau, you can put whatever data in you want in the same way you can do it for Docker. So you can say, go and get me this SID or IPFS, go and get me the URL, put them in the job. You can put environment variables into the job. You can put program arguments into the job. You can do standard out, standard error. It looks kind of similar to like a normal program, so that's cool. Now, I know what you're thinking. You're like, Simon, Dave already did that demo yesterday, and you're right, he did, so I haven't actually shown you anything new. So I had to do a new demo. So I've done a new demo. So what this is an example of what I think is quite interesting, which is building generic utilities and storing them in IPFS as a kind of library. So here's my example. I downloaded 2,000 horses of Wikidata. I ran a Bacalhau job to transpose them into a list of their parents. And then I've compiled this program, which is on GitHub down here, big props to the author of that program, into WASM. And you can now access that program on IPFS at this location in WASM. And when I run that across my horses CSV, I will get my horses in a Parquet format. Now that's kind of cool. It's quite a generic transformation. It should be useful for lots of different things. Like lots of people have CSVs because they open them in Excel, right? Fewer people have Parquet, but we like Parquet for lots of good reasons. So maybe it would be nice to be able to simply run a transformation over the data already in IPFS and get it out again. This was a comment I added following Kai's talk, like maybe this is such a useful transformation or such a generic transformation that we could bless these programs and give them automatic fill plus based on the fact that it's not altering the data all that much and we know that it's good. That's just an idea. Demo. So I will do it again. So this is my first job, getting the horses into their parent and children mode. So I'm not going to download all the results because it's literally 2,000 horses. I don't think you need to see it. And I've already done it, so whatever. But now I'm taking the output of the horses thing and putting it into the CSV to Parquet, and actually what I've done obviously is taken the CID results out of the first job and put them as input into the second job. So actually I've never touched any of this data on my computer. That output from the first job, I've never seen it, I've never downloaded it, I don't need to see it. But now I've got my Parquet file, and to verify that it does actually work, I will come and find it. Yeah, there it is. There's a Parquet file. I won't open it because it's binary. But essentially, it does work. So that's cool. So that's kind of what we can do right now in Bacalhau. Oh, yeah, also, I should say that this is not an opinionated WASM blob that we've put here. Like, this is just a generic blob of WASM. It's nothing to do with Bacalhau. There's no Bacalhau-specific stuff in here. So if there was another compute provider like Koi, who could run WASM. I don't know if Koi can run WASM or not, sorry. But if they can, then they could take the same CID off IPFS and run the same job. That seems like quite useful. We can together build a generic library of utilities that make things like cleaning data, which is like 90% of a data scientist's job, easier, which feels like a nice thing to do. So something that's coming soon, I suppose. I already showed you how we imported a WASM job from IPFS. We can extend that in quite an easy way to essentially have modules interlinking on IPFS. So I can say, if I've got a program, I don't actually need to download all of the WASM modules I need to run it because they're all in IPFS already. So I can just tell Bacalhau to go and get these WASM modules, chuck them in with mine, and run everything. So it's quite easy to do that as a manual step, especially if you know what you're looking for. We can also look at doing it as an automatic step. So it's possible to do something like embed the CID of the modules that we're linking against into WebAssembly itself, and then Bacalhau can go and look it up and do it for you. It also means that we could do something like have new versions. So one of the things that Juan talks about in one of his many talks is the ability to kind of auto-update. So you could do something like this where you've linked against Pandas 1.0, but actually we can silently upgrade that to Pandas 1.1 and fix security bugs because we've kept a cache of the old version CID to the new version CID, or something like that. Something else that I was trying to do while I was doing this demo was make it easier to run languages, because no one had heard of WebAssembly when I started the talk, right? So you don't really want to compile things to WebAssembly and run them. What you actually want to do is run your program. So maybe your program's in a Rust thing, so actually maybe you should be able to pass that to Bacalhau and say, hey, here's my Rust, run that, and Bacalhau can work out how to run it. Maybe it'll run it by compiling it into WASM, and then it can run it as I showed you, or maybe it can run it in a Docker container. It could decide how to do that for you. There's no reason that you need to decide how to do that yourself necessarily, unless you want specific guarantees. This is quite early, but this is the sort of direction that we'd like to go to make it easier, to reference Luke's talk, to run stuff in a deterministic way. One final thing is I've drawn lots of diagrams here with arrows and boxes. You might have seen that when I did the thing with the terminal, that I had to basically run one job, get the results, put the CID into another job, run that. Oh my God, what pain. And it's too much for me. So clearly what we need is a orchestration system, a workflow system. The last member of the Fab Four, Enrico, will be talking about that in a moment. So get ready for that. Finally, some stuff that I would like to note from people in the room. WASI, what do we think about it? Is it a good idea? What would we like to see? Can we influence the future of that spec? Do we think there's something better that we could do with it for Bacalhau or for IPVM, or for just Web3 stuff in general? Or is there a better system interface for big data that doesn't look like POSIX, but looks like something else? And then finally, please tell me what languages you'd like to use, because we know that Rust has good support, but are people writing code in Rust that they want to run a Bacalhau? Not sure. Python, definitely people are, and we can do that. But what else? What other sort of jobs would you like to run in a deterministic way and pay people for? That's it. Thank you very much for listening.